Now let's discuss the significance tests with two means. When performing significance tests with two means, the same conditions as with the confidence interval discussed earlier in the topic apply. A two-sample t-test for two means is similar to its predecessor of one mean, but it has the following differences. First, the null hypothesis changes to be h sub 0, or our null hypothesis, is that our mean for set 1 minus the mean for set 2 is equal to a hypothesized value. In other words, it doesn't always have to be equal to 0, as we've seen before. The second condition is that the following formula computes the t-statistic. T is equal to the sample mean for set 1 minus the sample mean for set 2. Take that entire quantity and subtract our hypothesized mean value, which is mu sub 1 minus mu sub 2, and divide the whole thing by the square root of our standard deviation for set 1 squared over the sample size for set 1 plus the standard deviation for set 2 squared divided by the sample size for set 2. And the third condition is that our alternative hypothesis will be that our mean from set 1 minus the mean from set 2, or mu1 minus mu2, is either less than, greater than, or not equal to the hypothesized value. Let's try an example for conducting significance tests with two means. Suppose a manufacturer produces light bulbs that are intended to last for 1,000 hours. A sample of 50 light bulbs is randomly selected from the production line and tested. The sample mean lifetime is 950 hours with a standard deviation of 80 hours. Another sample of 60 light bulbs is selected from a competing manufacturer's production line and tested. The sample mean lifetime of the competing light bulbs is 970 hours, and the standard deviation is 70 hours. We want to test whether the mean lifetime of the manufacturer's light bulbs is significantly different from that of the competing light bulbs at a significance level of 0.05 or 5%. Let's get started. First, let's double check to make sure that all the conditions are met in order to perform the test. So we know that we have a sample of 50 light bulbs, and they are randomly selected from the production line and tested. That's how the first sample was created. And now our second sample is 60 light bulbs selected from a competing manufacturer's production line and tested. So the first condition of being random is definitely fulfilled in both cases. And the sample size definitely is less than or equal to 1/10 the actual population size or size of the actual production line that each company has. And the third condition with the large counts is both of these values, 50 and 60, are greater than or equal to 30. So they totally fulfill the large counts requirement as well. And because all these conditions are satisfied, we can write the hypotheses for our experiment or significance test. First is the null hypothesis, and we're going to say that both of these companies, their means, are equivalent to one another. So the mean lifetime of the manufacturer's light bulb is equal to that of the competing or competitor's light bulbs. So then the alternative hypothesis will be that they are not equal. The mean lifetime of a manufacturer's light bulbs is different from that of the competing light bulbs. The next step is to perform a two-sample t-test for our two means. So we're going to need to evaluate and fill in, first substitute in all the data values that we have from our problem into the formula, and then evaluate. So if we look at our problem, we have the sample of 50 light bulbs. This is our N1 value. And its sample mean is 950 hours. That's going to be our x sub 1 with a bar over it. And the standard deviation of 80 hours. That's going to be our S sub 1 value. Another sample of 60 light bulbs, that's our N2, is selected, and the sample mean for this light bulb is 970 hours. That's our X bar with 2 in subscript, and the standard deviation of 70 hours, that's our S sub 2. So in this case, we have all of these values, and if we assume that the null hypothesis is true, then mu sub 1 minus mu sub 2 is equal to 0. The next step is to substitute our data values into our formula and simplify. So again, we have our formula, and now we know that our mean for set 1 is 950 hours, so I'm going to substitute that in for x sub 1. And similarly, our x sub 2 value is going to be 970, so we're going to substitute those in. And then minus mu 1 minus mu sub 2, since we're assuming that is to be 0, we substitute that into its place, and then we fill in the remaining values for our standard deviation for each set. So we have 80 squared over 50 plus 70 squared over 60. And if we substitute these values into a calculator and evaluate, we get a value of -1 and about 381 thousandths. Using a two-tailed t-distribution table or an online resource that can calculate the p-value for the t-value found, we find that the p-value for this test is 170 thousandths, or 0.170. And here's what the website shows. We put in that t-score value from the previous slide, calculated the degrees of freedom by doing our 50 plus 70, 50 plus 60, and those values were found here and here, minus 2, which gives us 110 minus 2, which is 108, so that's our degrees of freedom. So we substitute that in to the calculator, say the significance level of 5/100ths, two-tailed, and then press the calculate button, and it provides us with the p-value. And the p-value is greater than the significance level, so we fail to reject the null hypothesis in this problem. And now that we have found the p-value for our significance t-test, we can draw a conclusion. We do not have sufficient evidence to conclude that the mean lifetime of the manufacturer's light bulbs is significantly different from that of the competing light bulbs.